Hi guys! I have done so many mock coding interviews on this channel, but this one is really special because a school kid mailed me and asked me to take his interview. And I was amazed by the way he has performed and his confidence. I don't want to introduce him, he has to do it himself. You will see the amount of confidence he has, the way he talks, and the way he has done in the interview. See it for yourself.
Hello everyone, I am Bharat Singla and I am a school student in class 10. I have reached 5 stars on CodeChef and expert on code forces, and I also won Google's Code to Learn 2020 hackathon. Recently, I qualified INOI and made it through to the camp, which is the final stage from which the top 4 will represent India at the IOI. So, yeah, that was a bit about my coding journey, and with that being said, let's begin.
Just one more thing before we start the interview, let me tell you about the sponsor of the video. Educative is an amazing platform with a lot of cool resources for all the software developers. You can check it out using the link in the description and use the coupon code Keerti to get discount on the subscription and get access to all their courses. One such cool course is Hacking the Coding Interview. As you can see, you will get 80 plus example problems and their solutions with step-by-step visualizations. You will get hands-on coding environment and there will be no setup requirement. As you can see, the content is extremely well structured. You will get content on arrays, linked lists, everything, and it will be very detailed, structured. And I think 85 plus problems is enough to help you crack any good coding interview. So do check it out. This might be really, really helpful. And once again, do not forget to use the coupon code KT. You will get access to not just this course, but to so many more such cool courses. So, Bharat, this is your question.
Okay, you're given two integers array, nums1, nums2. We write all the integers of nums1 and nums2 in the order they are given on two separate horizontal lines. Okay, so basically they represent coordinates on on the x plane. Okay, connecting line is straight line connecting two numbers such that nums1 equals num2j and the lines we draw do not intersect any other. Okay, okay. We can only belong to one connecting line. Maximum number of connecting lines we can draw.
For example,
Example, yeah.
nums1 is 1, 4, 2 and nums2 is 1, 2, 4, then you can connect 1, 1 and 4, 4 or 1, 1 and 2, 2. So basically two uncrossed lines.
Okay. So, okay, the basic approach is like to find the number of common elements that they both have. But the issue there is that we cannot intersect the lines, right?
Right.
Okay. So, isn't it like DP okay? I'm thinking, let me just consolidate it. Yeah, yeah, I think this is like DP, and I think this is a common algorithm. The problem statement is just a convoluted form of this. It's about the longest common subsequence here
Okay.
because that will be in the same order as well as that will be the longest which we can have of same numbers.
Okay.
Yeah. So, should we start coding it?
Sure.
Okay. So,
Longest common subsequence is what you said, right?
right, right. Oh yeah, nums1, nums2, right. Okay. So, I think I'm trying to use a different function for LCS, but I don't think there's anything except finding the LCS. So I just write the DP code here itself. So after this, once we probably create an array of size n cross n plus 1,
Why?
right?
Why that plus 1?
Because we'll be working with one-based indexing here. LCS is very convenient to implement in one-based indexing. Yeah, it just got converted, please. Yeah. So the basic relation is that dpi of j denotes the answer for the first array, the prefix till I, the first I numbers, and the first j numbers of the second array. So if they do match, so if nums1 of I minus 1, because even though our DP array works with one-based indexing, we still have to use I minus 1 to access the ith number. If that is equal to nums2 of j minus 1 again, then dpi of j becomes 1 plus, I'll just put it on a new line, right? I minus 1 and j minus 1. Otherwise, I have dpi of j becomes maximum of I minus 1 and j. So we cannot match them, but we can obviously try matching I minus 1 and j, as well as I and then j minus 1.
Can you explain the condition once more? Like why you are doing this? Like when it is equal, why you are adding plus 1 and...
Yeah, so when basically, say we are talking about this prefix here and this prefix here. So 4 and 4 match, right? So we should always match them. There's no point not matching them, because if we do not match them, we'll probably match this 4 with some 4 on its left. So it's always better to match them, right? When we have a 4 here. But if they do not match, so if they say there was a 3 here, right? Then we should try either matching 3 with, if there's a 3 here, or it doesn't really depend. The first 3 we'll probably find here. But the other case we need to consider is that when we are matching this 4 with in this prefix, right? So that's I minus 1, the first I minus 1 numbers with the first j numbers of the second array, or the first I numbers with the first j minus 1 numbers of the second array. If we do not take the max, then it can be solved with greedy as well, right? So some part of this DP, this part here is actually greedy. When you have a match, just match them. Otherwise, we do need to consider both the possibilities when we are either removing this element from the array because it cannot be matched, or this element.
Okay, what is the space and time complexity of this?
Just a second. Space and time complexity will be n into n.
Can you optimize that?
What part?
Space.
Space.
Can you optimize time? Like, is it possible?
No, time is basically not possible to optimize. But yeah, I think space is optimizable because we are only referring to I minus 1 and j minus 1, as well as here I minus 1. So it's either the previous row and the previous column, the basically the number on its top left, or it's about the number above it in the 2D matrix basically, and the number on its right. So for each number, what we can do is probably store these 3 values, right? Or in general, what we can do is probably store the above line, right? As well as j minus 1 can basically be accessed from the above line itself. And here it's a, so basically this transition is from the previous line. So if we store the previous line, that works. Basically I minus 1 row. This is also from that. And this is just the, the previous number on the current row itself. So we can maintain 2 rows, current and the previous. After the loop, we'll set the previous to the current, and that way we can optimize space complexity to O of n. In fact, what we can do is swap nums1 and nums2 if nums1 is smaller than, if nums1 is greater than nums2, then swap them. And the reason for this is n could be very big and n could be small. So here it's about the product, right? The time and space complexity is n into m. So it doesn't really matter. But when we are optimizing it to O of n, if n is really large but m is really small, we can also optimize it to O of n by swapping nums1 and nums2.
Can you write the
Yeah.
can you make the code changes for that?
Yeah. So I'll make that change later because asymptotically it doesn't really help by swapping them. Okay, let's just add it's just one line. So if n is greater than m, swap n and m as well as swap nums1 and nums2. Right? This way n will always be less than m, and our time complexity O of n makes much more sense. So so we'll essentially have okay, I'm just commenting it out. Previous row that will be of size m. Yeah, as well as current row also of size n. So what I'm trying to remove here is this part. So let's comment this. So dp of j, in the end, let's think about what we are to return. Okay. So in the end, I'll be returning current of m, right? The last row's last number basically. That was previously dp of n of m. Right, so this is what I'll be returning. These two loops are necessary. What we're optimizing is that current of j will be 1 plus previous of j minus 1, and here current of j will be yeah, again here the sizes would be plus 1. Current of j otherwise would be maximum of previous of j as well as current of j minus 1. And finally after this loop we'll set previous to current and possibly reset current. Yeah, or we can use fill as well here.
Okay.
Yeah, so this should be fine now. This part is commented. So space complexity will be O of n, O of m, perfect. Right, so I think this should be, if this is less, right, or if to make it more idiomatic, if m is less than greater than n, so we'll swap them. So m will obviously be less than n now. So the space complexity.
There is one mistake in your code.
Yeah. I just reread the code. Okay, so we are iterating on the rows. Then I'm iterating on the columns if they do match. So current of j. So dp of I is what we are replacing with current, right? Yeah, okay. So this is 1 plus. Oh, okay. Yeah, this should be previous.
Okay.
Yeah, because in the last iteration we'll set current to all zeros, so that doesn't make sense.
Do you actually need to assign it to 0? Like,
So we actually do not need to assign it to the whole array possibly, because we are referring to current of j minus 1 when we are accessing current of j, right? So indeed j minus 1 should be completely refreshed in the new iteration, but that before that is set, j minus 1 is already set because j is iterating in increasing order.
Hmm.
So the only case is when j is 1. In that case, it's accessing 0. So we can, I think, just possibly set current of 0 to 0. And in fact, that is only accessed and not set. So that will always say 0. So yeah. It doesn't improve the time complexity, but does possibly improve the runtime a bit.
Hmm.
Yes, I'll just remove this. This was for my reference. Yeah, okay.
Great, sounds good. Let's get to second question.
Yeah, I mean, it's around 15 minutes now, so
Yeah.
13 minutes. Yeah, so we can get to the next question.
So here's the second question. Just read through it.
You're given a zero index integer nouns, array nouns, and k. You're initially standing at index 0. In one move, you can jump at most k steps forward without going outside boundaries. That is, you can jump from I to, yeah, sure, okay. You want to reach the last index of the array. Your score is the sum of all nums of j for each index j you visited in the array. So k is our limit basically. We can either jump one position forward, two position forward, so until k positions forward. We want to reach from the start of the array to the end of the array and want to maximize the sum of all the numbers we visit.
Yep.
Okay, so the problem is kind of recursive in nature because once we make a jump, it's all about the sub problem that's left. It doesn't really matter what jump we made or whatever. So for each position, yeah, and it can have negative numbers as well. Otherwise, it was obviously always better to jump on the positive ones only. Yeah, that could have been possibly solved by greedy, but this I think will require DP. So another DP question, and what I'm thinking of is like, uh, could I change the font?
Sure, yeah.
Yeah. So I'm thinking of DP of I that stores best answer for uh, array till I, inclusive of I. Right. So what we'll do is the transition will be like DP of I is you have I, so you'll obviously add I to your answer, and then you have DP of I minus 1 plus DP of I minus 2, so until DP of I minus k, and you take the maximum of all of them. We want to maximize the sum, right? Not minimize.
Return the
Sorry.
maximum score you
Right,
can
right,
get.
right. Yeah. Perfect. So this is the DP, and there will be n states. Transition is complexity of k. So we have time complexity of O of n into k. Should we optimize?
Yep.
Yeah. Okay. So, hmm. Okay. So what I'm thinking of is that this is essentially a sliding window of size k.
Okay.
So we want to maintain a minimum sliding window minimum or something like that. Maximum, sorry. Yeah. So that is actually very lengthy to implement. I'm just thinking of something better. So yeah, there's obviously solutions like segment tree. That would be like, because you can always have that code pre-written, so that might be easier to implement. And then it's the complexity will be like n log k actually. Yeah.
Is it really that hard to maintain
Yeah,
it?
yeah, yeah. Yeah, yeah. It's not really hard. If you want to code from scratch, then segment tree will take like 100 lines, whereas you can implement that with a monotonic queue, I think. Sliding window minimum,
Which other data structure can you use?
sliding window maximum, sorry. Uh,
You need to keep tab of the maximum value.
Right.
Which data structure keeps the maximum value?
It's actually about maximum in a range, right? Otherwise, we could have kept a max prefix max, something like that. But max is again not a subtractable quantity, so I cannot subtract the maximum till I minus 1, and from that till I minus k minus 1. Mm,
What if? Okay. Think about it. I'm not giving you
yeah,
any
yeah,
hints.
yeah, okay. Okay. So we probably want to maintain a multiset here, and a sliding window shift is like removing the left element and adding the right element, and the minimum will be stored at the set, the begin of set. That's n log n. N log k actually, because the size of set will always stay k.
Right.
Yeah.
Other than multi-set, which similar data structure can you use? Like,
We can use a priority queue as well.
right.
Yeah.
Uh,
So
how is
code.
why is like how is priority queue internally implemented? Do you have any idea?
So priority queue is like a heap. We can maintain a heap in C++. It's called priority queue.
Okay, got it. Can we use a priority queue?
Mm, Actually, the issue with priority queue will be, uh, we actually can use a priority queue because it's just about finding a max. Oh, you possibly mean a max priority queue.
Yep.
Yeah, so max priority queue is definitely usable. I am just finding it hard to recall if C++ allows to store duplicate elements in a priority queue.
It does.
It does, right? And if even if it doesn't, then we can store the number and its index, a pair of that. So that will help us. Even if two numbers are same, their index will be different. So yeah. But yeah, I think it does support. So we can use a priority queue. Complexity wise, set and priority queue both will be the same, but may improve the runtimes about 3 to 4 times. So code.
Uh, the fact that you said that let's just store the number and the index.
Hmm.
Uh, okay. How are you taking care of the k within the k value range? The window thing.
So the base case will be like, the first k values I think we'll have to store as a base case in dp of like dp0, dp1, dp2, so until k.
Then.
And after that, we'll add all these elements to the priority queue. We'll maintain 2 pointers, or we can use some basic arithmetic to get the start and end. We'll remove the left one from the priority queue
How are you going to remove the left one from the priority queue? Does
because we'll know
priority queue
that.
support that? It's a queue.
mm, right, it's priority queue actually, I think. Yeah, okay. So priority queue will possibly not store that number at the top. It will be somewhere in the middle, and priority queue only supports either popping the smallest element or pushing it, right? Okay, yeah. So priority queue cannot be used here. Yeah.
Can it
We
not be
can
used?
we we can use it if we store the index before the element, and that way we can uh actually no, I think. Just a second.
Think about
Should
it.
I
Think
should I
about it.
implement should I start implementation with the set and then possibly think about it, because the code might help me get a bit more clarity.
Okay, with set also, but before you start coding, I want you to explain me the
Yeah.
approach. I'm not going to let you code
With
without
set or
me.
with priority queue?
Let's do with set if you are more comfortable with that.
Yeah. So the basic thing here is that we want to store the best answer for a of till a prefix of the array. Basically, we are using DP here. So then we want to transition because we can jump. We could have reached there from either I minus one or I minus two or I minus three. This will be a bit easier to implement. The other way to do this was probably iterate from the right and then take the max of I plus 1, I plus 2, so on.
Right.
Right, that is another way. And that makes a bit more sense based on the story we have here, because this dp of I actually stores from where we are coming from, whereas if we iterate from the back, it's about where we are jumping to. Right. So we could have either come from I minus 1, so this stores the best answer from there, or from I minus 2, or from so on till I minus k. And obviously, because we are considering that we have visited the ith position, we have to add this as well. Right, so this is the basic transition. The complexity for this will be n into k, but what we for sure know is that this is the size of the number of arguments here are k only, and it is a sliding window. When we move I by 1, this window moves by 1. So we want to essentially maintain basically a sliding window minimum, and we want to slide it when we move I. So this is the basic approach. So what I'll do is probably dp0, dp1, dp2, they are all essentially right. Basically, they can be solved by simple brute force only. And after that, once we've initialized the base case, what we'll do is we'll maintain a set of all these numbers, actually a multi-set because they could be duplicate elements. When we go from I to I plus 1 in the new iteration of the loop, we'll remove the I minus k minus 1, something like that element from the set, because that's no more part of the window, and we'll add I to it. Right, this way we'll maintain a sliding window, and because we are using a multi-set, it stores the element in sorted order, and we can access the maximum by accessing the last element.
Okay, start writing the code. Then
Yeah.
let's see.
So max score, the only input is here in nums as well as k, right? Oh, I should have probably added const there. Right.
Okay, cool.
Nums as well as integer k. So here what we'll do is we'll I think, yeah, so we'll have a multi-set. Yeah, and I definitely would like to mention that this problem can be solved in O of n also. This would be n log k by using a monotonic queue. Right, the code would be quite lengthy, I feel 30-40 lines.
What is a monotonic queue?
So what we basically want is, okay, I try to explain it a bit. So we have a lot of numbers.
Okay.
We just want to store the maximum, right? So we just have a few numbers. Then when we move one position to the right, if we encounter a greater number, then we'll remove all the elements that are smaller than it, because they're of no use now. That's the basic idea. And that way our queue will always be sorted. It will, because we are using a queue, every deletion and everything will be of 1, and the maximum element will be stored at the end of the queue.
Got it.
It's like a monotonic stack only.
Yeah.
So multi-set of int that will store the window initially empty, and then I'll iterate on first k numbers, right? And let's maintain a deep here as well. Perfect. So I'll just write what we'll return in the end. We are working on this problem with zero-based indexing only. Okay, so we go from 0 till k, and what I do is I first add it to the window, or in fact I'll add it to the end after we have done after the body is done. So window.insert a of I, right? And what I'll do is because here there is no point removing any element, the window size is obviously less than k, right? So for this array, basically here you don't have to remove the leftmost element, here you do not have to remove it, but when you come here you have to remove this. So this is the base case. So dpi is essentially previous of end of window star, possibly, yeah. Yeah. So this will give us the last element. We can also store the negative of a of I in this to just use begin, but yeah, this makes much more sense. Okay. So yeah, this is basically the code for this for the base case. First, yeah, really sorry. A of I plus. We want the maximum, right? Okay. Of window, and here we'll not insert A of I, we'll insert dp of I.
What is A of I?
Sorry, nums of I, yeah. So nums of I plus the window is storing the maximum. This way we can extract that, and in the window we'll then insert dp of I as well.
In the first
Hmm.
time, the first
Hmm.
time when you go inside this,
Hmm.
it's
Yeah, we'll probably have to either iterate from one or add a ternary condition here possibly.
your code would have crashed.
Sorry.
Your code would have crashed.
How? I mean,
It would have
without this,
written,
right?
yeah, yeah.
Yeah, okay, okay. Yeah. So empty window, that is 0, otherwise, yeah.
Hmm.
Perfect. So now I'll just have yeah, so this is the two pointers, maintaining the end of the window and maintaining basically the rightmost part of the window, and one and j stores the one left to the start. So that is what we'll remove from the window. Now we do not want to erase all the occurrences of that number. That's one caveat with multiset. So we'll find it first. Window dot find a of j, nums of j, right? And this code will be the same. Yeah. So windows, from the window we erase j, we add I, and before that we set it. So here we basically do not need this condition. The window won't be empty because we have already added k elements to it. I can assume k is positive, right? Otherwise, the the person who's jumping will be stuck on that same stone forever.
Yeah.
Yeah. Okay. So this should be fine. Yeah.
Okay. So now how you would have used priority queue in this case?
Okay. So priority queue helps you to remove elements as well as, because I think if you have this functionality of finding the maximum, right, then you should not put the index before the number, because then you'll not get the maximum, right? So the number has to be before the index. That way you can get the maximum, but then you cannot pinpoint that, hey, remove this element, right? So I think so priority queue might be unusable here. Maybe some hack could do this, but as far as I can think of, it's impossible to use it here.
I'm telling you there's a hack. Now can you think of a hack?
Okay, okay. Yeah. So let me just recall the syntax of a priority queue. So it
Let me
stores the elements.
let me give you a hint. So here you are erasing the elements which are basically outside your window, right?
Hmm. Hmm.
Similarly, in priority queue, it's not in your hand, but when you come across an element like the biggest element, and you know that okay, this is
Okay.
outside, just don't consider it, no?
So actually, that is essentially monotonic queue only,
Right.
because you will keep removing elements until they are out of your window scope. then the first position that you find is within. So basically, yeah, we'll need to store the index as well, right? Or we can use frequency and subtract frequency and also. But yeah, index is the best way.
You
So
had
I'll just,
actually given the hint to yourself, like okay, since you're doing it. Yeah,
yeah,
continue. Yeah,
yeah,
continue.
yeah, go on, go on.
No, continue. I want to
Okay,
see
okay.
you write the code. Yeah.
Okay, so priority queue, this will store. So by default, it's max priority queue only. So there's no issue here. So so this is crap now, basically. So DP of I is nums of I plus have a function possibly get first within the window.
It's basically priority queue top.
No, I mean we'll have to take the top, then we'll have to remove it if its index is lower, and we'll have to do this again and again, right?
Right now you're doing for first k elements, right?
Uh, oh yeah, so here it's not here this is not required, right. So this is, I forgot that there are two loops here. So this is the logic for this part. Yeah. So here what we can do is, yeah, we'll have to use top. So what I mentioned, yeah, window dot, is it top or is it front? Okay, it's top. Yeah. So it's window dot top, and here what we'll have to do is get first within, probably have a function.
Also, it's
Or
window dot push.
all right, yeah, window dot push, and here it will be window dot pop, right?
Okay.
So here we cannot use pop. Okay, so I am getting it.
Calm down
So
a
I
bit.
think
Calm down a bit and
Mhm.
write code properly while pushing what are you supposed to push in your priority queue. Push properly.
Right. So I think I messed it up because it was working with sets. So probably just revert back to what it was, and I'll rewrite this code.
Okay.
So max code, this will store a priority. Okay. Right. And here we have a priority key of pair of int and int. So window dot push, what I'll be pushing is a pair of dp of I as well as I. Right. We cannot make it I and dp of I, then otherwise pop won't work properly. Right. This part changes to, okay, so this is again 2. This part changes to the maximum, and that will be window dot top dot second. Right. So this part is fine.
Wait, second. The first is what? Second is what?
I don't know what I'm doing, a blunder here. Yeah, dp of I is
I
what we
need
want.
you to calm down. You're doing great. Okay. Yeah.
Okay. Perfect. So this is not needed. We do not want to erase anything. But here, when we are popping, we have to make sure that it is within. So I just modularize my code, get within. Okay, so get within, what it will do is it will return me the first pair, and it will obviously keep it will pop in the order of maximums only. So the first number whose index is less than 5. So while window dot top, we actually don't need everything by reference. So while window dot top dot, here we'll use second, is Okay, we'll have to pass in two parameters here. That will be j. I'll just change it later. Yeah, so this will have j and is greater equals is less than j. So it's out of the window. In fact, j denotes one left to it, so less than equals j. So while it is out of the window, what we'll do is window dot pop. Now, we do not need to worry about the window becoming empty, so we can return window dot top dot first. So while it is on the left, right, we keep popping it, and now it stops towards the maximum value, which is greater than k. So we can return window dot top dot first. We'll need a semicolon here. I'll just change it to function of int yeah, perfect. So nums of I plus get within, and here we need to push. So we do not need to worry about removing anything. This function will remove the numbers on its left.
You could have actually written just one for loop, but that's fine. Yeah. Cool.
Yeah, I think function. I do not use this while participating in contests, but
Right.
what I've heard is in interviews you should modularize your code.
Okay.
Yeah.
What's the time complexity of this?
It will be n log k.
Okay, great.
Actually no, because once we amortize this, it is now like 2 pointers. So we are iterating on n, and we are just removing one element, we are adding one element. So this part will have k log k, right? Because this is still k, and insertion will take log k. And then this part here, right, get within will add each element at max once into the array and remove each element at max once from the array. So the amortized complexity of get within will become O of n only, right? But popping will take log n. So yeah, the complexity becomes k log k plus n log n. K log k is a bit less powerful, so time complexity will become O of k log k plus n log n. Here n log n will be much more dominant.
What is
So we can
n log
remove
n?
this.
What is k log k? Explain again.
So the complexity of this part here, right? This will be basically it's just O of n, because ultimately each element is being pushed once and removed once, right? So after you amortize that, in one iteration there will be a lot of popping possibly, but in the next then there definitely will be less popping, right? So in total it will take O of n. But because we are working with priority queues, popping, pushing takes log n, so complexity becomes n log n. There is additional k factor here, but k I'm assuming is less than n, because k denotes a jump, so that will not increase the time complexity. This is the bottleneck of the code, basically the dominant part of the time complexity.
Cool. Sounds great.
Yeah.
So let's get to feedback now.
Yeah, sure. Let's get to feedback.
So, Bharat, how was your experience of interviewing?
Yeah, definitely it was awesome because it was the first time for me. I gave an interview for the first time. So yeah, I
Ever,
mean,
like
I
any kind of interview?
yeah, ever. So it was quite fun because I could actually apply whatever content I had consumed on interviews. You
Awesome.
know,
Yeah,
yeah.
you were saying something.
Yeah, so basically when you do not have much interview experience, the only thing left is to possibly watch your channel on interviews, right? And then learn how to modularize the code, how to write good variables names, not use f for functions or j and I for variables.
Yeah,
And yeah, it was a bit different from usual participation in contests that I do. Yeah.
it did not seem like it was your first interview at all. You were able to do two questions, and I also pushed you a lot. Like the first question was the conventional LCS question, but usually what happens, such a big question itself can be intimidating for some people, that what is written, like you have to read the question and understand that, okay, this is LCS question. So I thought, okay, let's just start with that. But you were not at all intimidated. You quickly picked it up. You were able to write the code. So I thought, okay, let's push you more. I asked you to do the space optimization. I actually have a video separately where I talk about such TP space optimizations, that from NM you can reduce it to 1D array from 2D array, right? So I pushed you there. Then I asked you another question. Now again I pushed you over there for space optimization. Then I knew you would be able to do by multi-site, but by priority queue you seemed a bit rusty, so I again pushed you there. But you picked it up really well, and definitely it does not seem like you're in 10th standard. So for the audience, when he made me for the first time, the first thing I asked him was to send me a proof that he is in 10th standard, so that I know that, okay, this is valid. I have to be authentic, right? So yep. And he has also taught a bit here and there, I think, in code forces, right? So before we did the interview, he just told me that people don't believe that he knows this much, and people assume that he has just mugged up, or someone has written the solution for him, script for him, and he is just coming and saying it. So I guess after this, no one will doubt you. I hope so.
Possibly, yes. And I wasn't expecting you to reveal this here as well.
But
Okay, never mind.
it does take a lot of guts, especially in 10th standard, the kind of confidence that you're showing, the way you're talking. I'm sure you have like great things coming up for you, because it's not easy to, like, I have interviewed so many people, and let's keep it very real. Like, this is not the first interview that I did with Bharat also. Like, we recorded, but something didn't work out, and then we recorded it again, and that's fine. Things happen. But this video, like this entire video was like interview. You can see how well he has performed, and I had no doubt that he will do this great. And when he made me, he was like, ask me a very hard question. He was like, let's keep it medium level and see how you do it. But you have outdone my expectations, like much better than I expected you to do.
Thanks. You're too kind.
Anything else you would like to say to the audience?
Definitely, I'd like to promote your channel a bit. So, if you are preparing for interviews, if you are preparing for system designs, data structures, algorithms, C++, and I think the list will go on and on, you can definitely subscribe to her channel. She's the best one doing it. So, do not waste your time searching throughout the web. Just focus on one channel, watch all the videos, and you'll possibly crack your dream company.
Thank you so much. Means a lot. And I hope you guys found the video helpful. Don't forget to like, share, and subscribe, and let us know in the comments how you found the video. Show a lot of love and support to Bharat also. He definitely deserves it. Thank you.
Yeah, thanks a lot. Bye. Thanks for having me here.